Now go on model, select multiphase. As you can see, there are 4 models. Wet steam is density based, the other are pressure based. Now pressure based is activated, select multiphase, actually go on model, then select multiphase and activate volume of fluid. Volume of fluid can model two heterogeneous fluid like mixture of water and oil. You must use the pressure based solver. Only one of the phases can be defined as a compressible ideal gas. The second order implicit time stepping formulation cannot be used with the volume of fluid. The volume of fluid formulation is generally used to compute a time-dependent solution, transient solution. And now activate mixture. The mixture model is simplified multiphase model that can be used to model multiphase flow where the phases move at different velocities. The coupling between the phases should be strong. It can be also used to model homogeneous multiphase flow. You must use the pressure-based solver. Only one of the phases can be defined as a compressible ideal gas. The last one is Aurelian model. The Aurelian model allows for modeling of multiple separate, yet interacting phases. That phase can be liquid, gas, or solid combination, but melting or solidification are not allowed. And close this. Actually, sorry, I want to off model and go on energy. If you want to observe heat transfer, you will activate energy equation. And okay. The other important thing is viscous. If fluid is inviscid, select inviscid. If flow is laminar, select laminar. And SA is a one equation turbulence model that has been developed specifically for aerodynamic flow, such as transonic flow over airfoil. And key epsilon. Key epsilon is so important. Generally we use key epsilon. Key epsilon model used for turbulence. It has 3 models: standard, RNG, and realized. Standard key epsilon model is typically used for external flow with non-complex geometry. It isn't memory intensive. And realized key epsilon model has improved for planar surface, rotation, recirculation, and streamline. It has high accuracy for planar and round jet. Another important modification is renormalizing group, RNG key epsilon model. The model was derived by attempting to solve for epsilon using the Navier-Stokes equation. The result was very much like the original equation. Key omega model is used for turbulence too. This is. Key omega model is used to model near-wall interaction more accurately than key epsilon model. Key omega model is that it may be applied throughout the boundary layer. It is popular for turbomachineries. It performs well for swirling flow and in the near wall region. There are 3 types, but this is new type. There is no information about that, so I don't know. And we have talked about standard. Now we will talk about SST. SST model is generally applied aeronautic area like airfoil application or airspace application. Some claims that performance of SST key omega is not very different from the release key of epsilon. The choice between the two will typically be made based on user preference. If you want to add radiation, you can activate this panel. If there is sun, you can activate this. This parameter will come automatically, and you can add heat exchanger and other options.